The next one. Okay. Are you recording? So list comprehension of list comprehension. See, first I have that list comprehension. Outside is over that thing. So this is like for j in that range. So this means the first list comprehension doesn't have anything to do with j, right? It's just for me to tell that, hey, I put this list in the outer list. 11 times. Okay, just that. From 0 to 10, 11 times. And I want to check, hey, when I create it by using nested list comprehension, and I create it using the for loop with append, are they the same? Yes, they are the same because I get true. Okay, y out and y out 2, they are the same. So anything that you can create it with list comprehension, like nested list comprehension, you can have the for loop for it too. Okay, I try to show you. Okay, that's the nested list comprehension. And if you want to write lists that contain other lists, like matrix, I use Pickle. Open r3.test and wb for Pickle. I think you have to use binary writing. Okay, I don't explain what is wb. It's just binary writing, but for Pickle, we just use that one. Then it works. Okay, you use Pickle.dump and f out whatever nested list that you have, and then you dump to where? You dump to f out, and f out is that text file. That's use Pickle, okay, to dump it. And if you want to pick it up, you use RB, reading. You use Pickle load. Okay, when you load it f in, right, as a result. And I print the result. Result is, look at it carefully. Result is not string. It doesn't have quotation mark. Result is nested list. Typically when you load something from file or you write something to file, you write it in string and you get string, right? But this time when you pick it up, you get list directly. Okay? So if you want to send list to file and back from file, use Pickle. When you pick it up, you get list directly, you don't get string. Result equal to y out or not? True. Okay, done. No question yet? Or with some question? You will try, right? And oh, okay, some material to keep out. Please. Let me get one. So that's a early access quiz 4 telling you that we don't have quiz for this coming Wednesday for certain, and we may have it later. So this Wednesday we don't have quiz. But if we have, the next quiz will, not this Wednesday, it will look like that. Now let's do deep copy. Okay, now I'd like to show you how copy work. Copy and assignment work. I import copy. Okay, import copy. I have A equal to dictionary, C equal to list. The first member of C is dictionary. The last, second, third, they are integer. D is C dot copy. Okay. This gives me shallow copy. Okay. And you will see the difference between shallow copy and deep copy. Shallow copy means it's very shallow, it's a copy, but it could be enough. Deep copy means it copy everything. Okay. But most of the time you may not want to use this deep copy. And let's see how does it look like. E equal to copy that deep copy C. So C contain dictionary and integers. Okay, that is C. And I do F equal to C. So F equal to C. I put it like that. So this means F and C, they are kind of the same thing. So you try to avoid that, okay? Let's take a look on ID. How does it look like? I have for loop to print out the ID. See, ID C of I is just what? 0, 1, 2, 3, 4. Okay? I is from 0 to 4. So ID of C bracket I, this will tell me the ID, right? And it will tell me, okay, what is that ID for? So for C0, I get that ID. That ID is memory location. Location in the memory. Okay, it's the same as address if you like ampersand in C++. The bracket 0, look at the ID. They are the same. Okay, C0 and D0. D0, D is a shallow copy. Okay, C is the original one. We try to copy the original one. C0 is what? Daniel, what is C0?
So C0 should be the string A because
no, it should not be the string. It should be the dictionary A. That A is dictionary. It's not string.
okay, so it's considered an element of C.
That A and that A, they're the same. It's an element of C. Yes.
Yeah, that's what I'm saying. So if we put A, which is a dictionary, in C, so we are discarding string A. And
So it's a string that contains dictionary. C is the list which contains dictionary and other integers. Okay, E0 is something else. E0 is not the same as C0. What is E? E is a deep copy. So if we do shallow copy, you point to the same memory location. If you do deep copy, you actually allocate a new location to store that memory, that information. Okay, so if you do deep copy, you create another copy. All right, but if you do shallow copy, you may not really create another copy. F0 is the same as C0. C0 is the original thing that we try to copy, right? F0 is the same as C0 because F equal to C. Okay. C1. Now let's take a look at C1. Okay. C1, that's the original thing that we try to compare. D1 is the same as, is it the same? Yes, it's the same as C1. And my D is shallow copy. Okay. E1 is the same. F1 is the same. Everyone is the same. Am I reading it wrong? It's the same as 140 blah 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 2704 2704 2704 2704. So C1, D1, E1, and F1, they are at the same memory location. What is C1? C1 is the original one. D1 is a shallow copy. E1 is a deep copy. F is the assignment operator. So if you do the deep copy, it creates a new copy just for the first member, but the second member, they're pointing at the same location. Why? I think that is because integer, they are immutable. Okay, because they are immutable. For immutable, you cannot change the value, right? If you want to change the value, you have to create it at a new location. Okay, that is location 1. What about location 2? 52736, 52736, 52736, 52736. The same. What about location 3? 527, 8, 68, 68, 68, 68, they're the same. Location D, location 4, they are the same. Okay. Deep copy, shallow copy, pointing to the same memory location, right? But now, ID. Okay. The first part is, this part is about location of each member. Okay. The second part is about location of the name itself, of the variable. We have variable C, D, E, F. Where is it? I'm not talking about the member inside, but I'm talking about that variable itself. Look at C. C has the different address than D. Okay? And C also have the different address than E. And C also, or C has the same address as F. Okay? So let's take a look on what is that about. When the name, if it have the same address or different address, what happened? The element inside, if it have the same address, different address, what's that about? So by now, you know that deep copy is the only thing that create the new storage for anything that is like dictionary. Okay, the new one. The rest they use same location, but the name itself, everything they are different except assignment. Assignment go to the same one. Okay, look at the original. The original one, if I add 20, append 20, add 20 at the end. Okay, I have 1, 2, 3, 4, and 20. So what do you think happened? So I add 20. The chain in C can impact variable that point to the same location, I think. So let's take a look at the first set. Okay, ID C, ID D, ID E, ID F. And then I tell C equal D equal E equal to F equal. When I append something, okay, I append 20, C had 20 as expected, okay, but shallow copy of it doesn't have 20. Deep copy of it doesn't have 20, okay, but the assignment copy has 20 because it is the same thing. So when you append something to C, F has something more too, but the deep copy and shallow copy of it doesn't have. Okay. Now let's take a look at this. ID of A and ID of C0, D0, E0, F0. A is the dictionary, right? That is inside. ID of A is that location. So ID of A and ID of C0 and D0, the original one point to that address of that dictionary. The shallow copy point to that address. Okay. But the deep copy create another dictionary. Okay, or point to different location. For assignment, it's the same. Okay. Okay, now A add U. What if I add something more into A? A is a dictionary, which is what? A and E. Oh, A, actually not dictionary, I'm sorry. It's a set. If you have colon, it's a dictionary. It doesn't have colon. Now A is a set, right? So when I add something to A, let's take a look at what happened to A. A is a set. Oh, okay. Now I have U. I add what? I add U into A. So I have U, A, E. Right? That is set A. What about list that contain that set? Okay. List that contain that set, I type C0. It's up there too. So it has U in that list. Okay. And shallow copy also have that U when there's an update of the member of the dictionary or of the set. But deep copy, whatever happened to the original set, don't think it do anything with deep copy. Deep copy stay the same even though there's a change in that set. Assignment, change of course, because assignment is the same thing. So this telling you that if you do shallow copy, whatever happened in the set, it can appear in shallow copy. But whatever happened in that set that is inside the list, it won't happen in your list, your deep copy. Okay, this is only for add statement, dot add method, and append. If I use something else, let's see. Sometimes copy, deep copy, work just like deep copy. Everything, assignment, copy, and deep copy work the same way. Look at this one. C equal to that, D equal to that, E equal to deep copy, D is shallow copy, F equal to C. So now, C is a list. Now I change to dictionary. Okay. Let's take a look on the address first. So when it doesn't contain any list, or when list just contain number, the address, they're unique, except the assignment, right? Assignment have the same address. When I change C equal to that, look at the address. The address 2808-9448. The address changed. Okay? So it doesn't really replace what you create on that address. It just points to the new location in the memory. Look at D. D stay the same. Okay, the value and the address stay the same. E stay the same and F stay the same. Okay, because when you use assignment operator, assign it with the dictionary, it points to the new location, but F still point to the same location. Okay, D and F just don't care, right? Because it's a separate copy. So what I'm telling you is that if you use just assignment operator, be careful. So whatever you change may or may not happen, but now you know how to check. That's my point. Okay. Now let's talk about how do we create several files. Several file approach. I go to Jupyter Notebook. Okay. I download PDF file. Actually, it's this one. This is to tell you how to separate file or separate code into several files. There are some good reasons for doing this. Each team member can do one part of the code, then combine later, right? If you write everything on one file, you have to, if, let's say your team have 3 people, you have to, for people number 1, and then finish the course, move on, something. So if you can separate the task into subtasks, use several files, each of you create one file and we combine them later. It makes code more readable, easy to debug. You debug just that file. When it works, it's good. Then you combine. And it's good for large program, but sometimes you don't want to separate it. So if your code is very short, don't separate it into several files. Okay? Code may become more difficult to debug if you separate it into several files. Program development time is shorter if not separate. Then you don't separate. If you split the file, if you split the code in several files and it's more difficult, you don't do it. If it's better, then you do it. So the time that you don't want to split or separate the code into several files is when your program is very small. Okay? But you want to know how you do it for the large program, right? Okay. When you separate the file, Python interpreter don't know automatically where's your file. Okay, so you may need to put underscore init underscore dot py. into that directory to tell that this is where you do the search when you do import statement. Without putting empty init file, this init file can be empty. I try with Jupyter Notebook and I try with just terminal code. It worked even though I didn't put the init.py. Okay, but in the documentation it said I should put init.py can be empty, but it should not be empty. Okay, you should write something. I will show you how. Okay, file structure. First, I'd like to introduce you concept about package. Package is folder name, directory name. Module is file name. Package is actually also module. It's a module that contains other module. Okay. Import statement, we use it to do the search. Okay. All right. The top level I have program. Backslash. I think it's slash. Slash over there is to tell that that is folder directory. In that directory, it contains main.ipython notebook, main underscore sub.py. Okay. And in that folder, it also contains another folder, pkg, package. In that package, it contains f underscore pk.py, or pk that is file, not folder. So I try to make it clear that anything start with f underscore, that is file. The rest is a folder. Okay. pkg1, so in that package, I have package 1, package 2, pkg1 contains another Python file. And I have pk1a, pk1b. I try to show you what happens if I don't use init. I put one init over there in pk1b. Okay. And package 2 just have file, folder, file, folder. Okay. All right. Let's take a look. You can download this to Jupyter Notebook. And did I give you just not enough? Oh, L2 code multiple file.zip. Okay. Extract all. Oh, I already have it. Okay. I get a folder called import example. I copy that into my main folder 5313. Import example. Let's take a look what's inside. Okay. I click import example. I have program and program 2. Let's focus with program. Okay. In program I have main. I have main sub.py. Let's take a look at main sub.py. Main sub.py have two functions. Main sub function 1, main sub function 2. Each function just print hello. So hello from main sub function 1, hello from main sub function 2. Just that. Okay. Let's take a look at main.ipython notebook. So I show you for the case where I don't put init. I just put one time over there. Okay, look. This main file is in the folder. I have ipython notebook, right? And I have another file which is main underscore sub.py. Okay. I want to use the code, which is these two functions in my ipython notebook. Notice that this is .py, not .ipython. Okay. I want to use those code. What do? I import it. Okay. Import main.sub. When I import, I don't add .py. Okay, just file name. So when I import that, main sub dot main function 1 I enter it, it print result. So basically, I can access the function in other file through the import statement. Yes.
What is that main sub like? You did it before for like import math or import copy.
Main sub is my own Python file. It's not other people's Python file, it's the user Python file. I create main underscore sub.py like that. Okay, it's my own. So when I import main sub, this means I import that file, that module.
So like what you did for copy, like import copy, copy is a file, or import math, math is a file.
Is the file, or sometimes it's a package that we don't know where it is. Actually, you should know. It's somewhere in your computer, but it's not from user. Okay. But this time it's my own. And you try to not make that name the same as like SciPy, SymPy. No, don't try to make that name the same as other people or the normal package name. Okay, make it kind of unique to you. So main.sub, main sub fn1, it call the function, right? I can access function that is in other file this way. Good. Because they are in the same directory, when you main sub2, I get hello from fn2, right? But if I ever just type main sub, I just type the function name directly. If I ever do that, I get error message. Okay. Now maybe I introduce you try statement. You will see many more of this later. Okay. I ask Python to try this statement. If any error occur, I consider that exception as E, and I print what error occur. So I can move on. I don't get stuck. Okay. So when error happen, it assign as E, and it print, okay, name main sub fn2 is not defined. So if I want to access that function, I use this dot. Okay, I have to use dot. File name dot that. Then we're good. Let's say, hey, I want file name main. I want to access the function directly. I don't want to use dot. What do? I use from main underscore sub. Main underscore sub is in the same directory. Okay, main underscore sub is in the same directory. I use main underscore sub. From main underscore sub, import that function. Now I can type that function directly. So main sub fn2 open close parenthesis, I can call it directly. So by from module name or package, import something. And okay, I didn't run it yet. Now I will show you why I want to access the function directly instead of using dot operator. Because using dot is a little bit slower. Okay. This line 6, 7, 8, I capture the time. I use magic function time it. I ask it to do 1 million times and 3 loop each or something. And then I try to show you, hey, what happened if I call main dots, if I use dot operator, if I access it directly, if I use dot operator, but use function 1 and function 2. I run this code. When I use dot fn1, I get this time. Okay. When I access the function directly without the dot, I get this time. Okay. It runs 1 million times. 1 million run 3 times. Okay. So T1 and T3, they should be the same. Okay. because the difference is just calling either you call this function or that function. So it should be the same. But what I show you here is if you access the function itself without using dot, it can be faster. Look at this, 0.4 and 0.36, 0.38 and 0.36, 0.397 is 0.390. Okay, it's a little bit faster. It's not that a lot. Okay, or sometimes you can have 0.4, 0.39, 0.392 or something. So use that name directly. It can be faster. Think about this. If you have several dots, then it may be a lot faster. But if you have just one dot, it's just faster. Okay, using member access operator, that dot make it slightly slower than calling the function directly. So if you use from something, import the function name, then it's good, right? Now let's take a look when we try to import the package. Import the folder. I put import pkg, that folder. I use directory or dir pkg. It tell me what's available to Python. Python don't know anything about, look at this one. In pkg, I have f_pk.py. Okay, but my program have no idea about that. Alright? Okay, so Python doesn't know anything inside. It doesn't know about pk1, pk2, or f_pk.py. So if I try to use package.pk1a, I get error message. If I try to use package.pk1, so if I want to use pk1a is folder name. Okay, I use from pkg.pk1, import that, dir pk1a. It doesn't know anything about what is inside. Because I didn't write anything for the init.py. I should write something. Okay. So if you do the import, it doesn't know anything other than what you import. The search happens just when you import. The dot thing is not that magic, okay? Look at this one. When I do dir, it doesn't know anything. Okay. What if your folder contains empty init.py? Okay. Even if you have empty init.py, you do. Okay, let's show you the structure a little bit. pkg.pkg1, so you try to go from here to here, right? .pk1b, which is this, and this folder has init.py. You expect that file name or that module should be visible. Okay, you import pk1b. When it starts with f, it's a file, it's not folder. So when you import that file, the function in that file is available. Just that file. It doesn't see any subdirectory. Okay. So when you use absolute import like this, it just import whatever you import. Just that. Nothing else. And it doesn't see anything else. Okay. But you may wonder, sometimes you do import scipy. Okay. And you have scipy dot, and you press tab. It has several other names for you to look at, right? So how do we do something like that? You write something in it, okay? Init.py. Okay. That's just to tell you, if your init.py is empty, when you import it, it just know whatever you import. It doesn't know something else. Okay, it's not even visible. Even if you have multiple files, you have multiple directory, it's not visible. If you want to make it visible, we have to initialize something. We have to write something in init.py. So this time, I try to use better package. In my better package, I have init.py, 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 init.py. Okay, I have init.py, and init.py, init.py is not empty. So for example, init.py that is in this better package directory is import that, and that folder. Whatever folder or file name that is in the same level. Okay, init.py here it import all these things that is in the same level. Let's take a look what's inside. So, better package. Let's take a look at init.py. See, I have from dot import that file, import that folder, import that folder. From dot here is to be used if you don't execute that Python file directly. You execute that Python file from another Python file. Okay, so you type from dot instead of the full path. From dot means the current directory. Okay, if you ever type the full directory name, it's going to crash. Because what? If you type from better package, this thing is in better package directory, right? If you type that better package directory that is not understand from your main Python file. Okay, so basically I import everything that is in the same level to initialize it. Better package 1 init.py is import everything that is on the same level. Okay, then I have this thing also import whatever that is in the same level, not include the subdirectory. Then what you have is if we import better package, and I type better package dot. Now I can press tab and it see what's inside. So let's say I select that thing. I have dot again and I press tab. Now it's visible whatever inside. Okay. The trick is you have to have from dot and import whatever that is in that folder. Then it's visible.
What is that SciPy for?
I answer your question just a little bit more. Let me show you this. Okay. Whenever you execute, when you try to import something, let's say you import parent 1. So parent directory. So your code is outside, okay? And this is a package name. In this directory, you have directory 1, directory 2, directory 3, and each folder has initialization file. Whenever you import parent.1 is this folder name, right? So this means you automatically run that and run that. Okay? So my init file, this file, initialize, import this one, right? And also import this folder. So when I have that folder import, it also import that. And that thing import everything that is in the same folder, same level. So basically, if you write it like what I did, whenever you import the package name, everything inside will be imported. Okay? Thank you very much. Question you can ask, please stop the video. See, oh, I forgot about the quiz. Okay.